So hi everyone, welcome back to another video on our channel. In this video, we are going to discuss another problem in our DSA series, that is Benjamin Ball's problem. And this is going to be our last video in the numbers section of our DSA series. So if you remember, we started the series with pattern printing problems, and then we moved on to numbers and how can we use the logic in programming to manipulate with different kinds of number, how to extract the digits of a number, how to check Armstrong number, palindrome number, prime number, how to check Pythagorean triplet. So we basically manipulated with the numbers. So this is going to be the last problem in this numbers chapter, and then we will move on to the next part. So let's start the problem. So this is not a data structure problem or any kind of programming problem. You can say it's more of a puzzle than it's related to programming because it confuses you very much, and you need to first crack the logic and then translate that logic into the programming part. So let's discuss about the problem and then we can find the solution. So in Benjamin bulb problem, we will be given n number of bulbs, light bulbs obviously, and all of them will be switched off at the start. And then we are giving the bulbs the voltage fluctuation n times. So what does this voltage fluctuation does is that every time it fluctuates, all the bulbs that will be turned on will be turned off. All the bulbs that will be turned off will be turned back on. So the bulbs will be toggled. So initially, if a bulb was on, it will be off. And if it was off, it will be turned back on. Getting my point? And every time the number of bulbs that gets toggled depends on the number of voltage fluctuation. For example, in the first time, all the bulbs will be toggled. In the second time, only the bulb that are multiples of 2 will be toggled. And in the third time, the multiple of 3 will be toggled. That means every third bulb will be toggled. Similarly, in the fourth voltage fluctuation, every fourth bulb will be toggled. That means multiple of 4. So we need to find out which bulbs or how many bulbs are on after n voltage fluctuation. So I think that explains the problem uh, very clearly and precisely. And also let me show you the problem on lead code as well. So let me read out the problem statement. There are n bulbs that are initially off. You first turn on the bulbs, then you turn off every second bulb. On the third round, you toggle every third bulb. Turning on it's if it's off, or turning off it's on. And for ith round, you toggle every I bulb. For the nth round, you only toggle the last bulb. So that basically sums up our problem. So how can we find the logic for it? So let's move into the solution. And as this is a puzzle type of problem, there will be no optimal or no brute force solution as such. There is just one solution basically, and that's a very easy one. And after the end of this video, you can solve this particular problem anywhere you can anywhere if you get it in the future. That's my guarantee for you. So let's dry run and understand the problem for the uh, value n is equal to 20. That means if we have n voltage fluctuation, getting my point? So let me zoom out a little bit so you can see it better. So I have marked this tick marks, which will I will explain you later. But I have used this B1, B2, B3 terms basically for bulb 1, bulb 2, bulb 3, bulb 4, bulb, till 20th bulb, because our n value is 20. So we have 20 bulb, and we will also have 20 voltage fluctuation. For n bulbs, you will have n voltage fluctuations. So when the voltage will be fluctuated first time, every bulb will be toggled. So initially every bulb was off, so it will be turned back on. So I have marked that with this red color pen. As you can see, the first tick for every bulb is marked with this red color tick. Uh, See the cursor over here where I'm pointing. So this red marks denotes that this is the first time that the bulb that has been toggled. So these are the first time when the bulbs are toggled. So when the second time bulb was toggled or voltage fluctuation happened, every second bulb was toggled. So as you can notice, I have marked that with this black color pen. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are the multiples of 2, and these bulbs will be toggled for the second iteration. For the third iteration or the third voltage fluctuation, every third bulb will be toggled. So I have marked this with the green ink. So B3, B6, B9, B12, B15, B18, and there is no B21, so we stop right there. So these six bulbs will be toggled for the third iteration. Similarly, for the fourth, B4, B8, B12, B16, B20. For the fifth, B5, B10, B15, B20. For the seventh or sixth iteration, B6, B12, B18, and we stop right there. For seventh iteration, B7, B14, and there is no B21, so we stop right there. For eighth iteration, B8, B16. And for B9 or ninth iteration, we mark B9, B18. Similarly, like that, we marked all the bulbs. You can do this yourself on a pen and paper. So after that, we observed something. So basically, in the first iteration, we toggled every bulb. The second iteration, we toggled the multiple of 2. Third iteration, we toggled the multiple of 3. And similarly, we repeated the same steps till 20th iteration, where we toggled only the multiple of 20, that is only this B20. So that's the this particular part. So what have we observed after putting all these tick marks? So we have observed that the odd number of tick marks, the bulb having the odd number of tick marks are on. Why is that? Because bulb was initially off. So when you have odd number of tick marks, that means the bulb is on. Getting my point? So here B1 was initially off and there is one tick mark. That means it's on. Here B4 has three tick marks. That means B4 was initially off. First tick mark, that means on. Second tick mark, that means off. Third tick mark, that means again on. That means every bulb that is having odd number of tick marks beside it is basically turned on. Getting my point? So simple logic. So the bulb was initially off. So you have to turn it back on one time so that it will be turned back on. So if you have odd number of tick marks, that means you have turned on, turned off, turned on, turned off, turned on, and turned off. Repeated this process many number of times, and at last you have turned it back on. That means every bulb having odd number of tick marks will be turned on. Getting my point? So initially off. So odd number of tick marks means on, and even number of tick marks means off. So that gives us one thing, that if our number is having odd number of factors, so these tick marks are nothing but number of factors of a given number. That is the number of bulb. So, so these tick marks are basically factors of that particular bulb number. So if a number is having odd number of factor, it will be turned on, and if a number is having even number of factor, it will be turned back off. So can you notice the pattern over here, that which bulbs are turned on and which bulbs are turned off? If you see bulb number 1, bulb number 4, bulb number 16, and bulb number 9. These four are the bulbs basically that are turned on. Can you notice a pattern? 1, 4, 9, 16. Perfect squares. These are perfect square numbers. And this number of bulbs are turned on. And one mistake is there. B16 will have another tick mark, which I forgot to give, which will make it a odd tick marked bulb. So because the factors of 16 are 1, 2, 4, 8, 16. As it have 5 factors, so 5 tick marks are bound to be there. So it will have 5 tick marks. So as you notice the pattern, the perfect square bulbs are the ones which are turned on. Why is that? Because they are the only numbers which have odd number of factors. So the perfect squares are only type of numbers which have odd number of factors. while the rest of the numbers have even number of factors, so they are turned off. You can basically verify it yourself that perfect squares have odd number of factors or not. So that's basically solves our entire problem, that among all the n given bulbs, which bulb will be turned on? Those who have odd number of factors or odd number of tick marks. And what are those numbers? Square numbers. So we just have to print the square numbers in the range 1 to n, and that's a cakewalk. We can definitely do that. So let me provide the solution to you over here. In the range 1 to n, we have to print square numbers. So we don't have to traverse each and every number. We just basically have to traverse the square number. So that's why I have basically given the condition I into I less than n, because we are traversing the square numbers, not the numbers itself. So let me also initialize a count variable over here, because it does not ask which number bulbs are turned on. Basically, it asks to return the count of bulbs which are turned on after n voltage fluctuation. So let me write. So what are the square numbers over here? So whenever our loop will encounter a square number, so this is our loop. It runs for 1 to n, and it traverses every square number in that uh, range. So a count variable is initialized, and the count variable gets updated for every square number in that range, and we have to return count. So let me check for the sample test cases, and it's running, and all the test cases have been passed. So let me submit the solution. As you can see, all the test cases have been passed, and our solution is accepted. So I hope you like this video, and if you have any doubts or any problems related to this video or any previous video, you can reach me out in the comments. Till then, keep learning. Thank you.